Okay, in Chapter 5, we're only going to do two lessons, Lesson 5.1 and Lesson 5.2, which have to do with multiplication and division of algebraic fractions. All right? The big idea for Lesson 5.1 and 5.2, now I've combined the two big ideas together, so therefore the combined big idea is that algebraic fractions are multiplied and divided in the same way that you would multiply and divide numeric fractions. The same things that you've been multiplying since 4th grade or something and dividing since 6th grade. Now the practice work for the lessons, I've given you about half as much practice work as normal since it's both 5.1 and 5.2. Make sure you skip the ones that are listed there. And let's talk about the concept. Okay, so algebraic fractions. First of all, what is an algebraic fraction? Okay, an algebraic fraction is any fraction that has a variable or variables in either the numerator, the denominator, or the numerator and the denominator. Okay, so those are algebraic fractions when they have any kind of variable anywhere in the fraction. Now these particular fractions, like right here, where there's a fraction within a fraction, is called a complex fraction. Okay, but don't let it throw you because it's basically just a fraction divided by a fraction, okay, which honestly you know how to do already, and we're going to talk about how you do that algebraically. Okay, multiplying algebraic fractions first. So how do we multiply algebraic fractions? Now again, the big idea said, how do you do it? You do it the same way you did numeric fractions. Okay? So here's the multiplying fractions property that says for all real numbers, a, b, c, and d, where b and d do not equal 0, how you would multiply a over b times c over d is just to multiply the numerators and get AC, and multiply the denominators and get BD. Okay? That would have been the same thing you would have been doing with numbers, like we're going to do right down here. Okay? Now, before we talk about how to do it with numbers and algebraic fractions, let's review why they said B and D cannot be equal to 0. Now, remember, you cannot divide by 0. It's impossible to do, so they call it undefined. So therefore, the denominators in any fraction cannot be 0. Okay, so let's talk about first multiplying numeric fractions, and then taking that same idea and showing how you use that to multiply algebraic fractions. And then after we do that, we're going to check it. Okay, multiplying numeric fractions. You have a very simple one here of 1/2 times 1/4. And as we said, you know, the property says you multiply the two numerators and you multiply the two denominators. So the numerators, 1 times 1, okay, and the denominator, 2 times 4. So in the numerator you get 1, and in the denominator you get 8. And that's something you've been doing for many years now. Okay, so how do we use that information to multiply algebraic fractions? Well, here's two algebraic fractions, L over 4 times W over 3. And once again, you would just multiply the two numerators, L times W, and the two denominators, 4 times 3, and you would get LW over 12. All right, now you might at this point just have to take our word for it and believe it because you understand the original property, but you can check it to make sure that you didn't make any mistakes along the way. Okay, so we're going to take the final answer that we had down here, LW equals 12, and take the original equation, which was L over 4 times W over 3, and use that for our check. So here we start our check. L over 4 times W over 3 equals LW over 12. So we're going to take numbers that are easy to work with, like 8 for L and 6 for W, and put those into the original equation and into the equation that you have as a result of your multiplication. Okay, so it becomes 8 over 4 times 6 over 3 equals 8 times 6 over 12. Well, 8 over 4 obviously is 2, and 6 over 3 is obviously 2. 8 times 6 is obviously 48, and the denominator there is 12. So 2 times 2 is 4, 48 divided by 12 is 4. Okay, so we checked it, and yeah, we didn't mess up anywhere. All right, let's talk about dividing algebraic fractions. Dividing an algebraic fraction is done the same way as numeric fractions. And dividing any fraction is the same as multiplying by its reciprocal. Okay? So the dividing fractions property says dividing A over B by C over D is the same thing as multiplying A over B times the reciprocal of C over D, which is D over C. Okay? Now remember, B and D cannot be zeros because of those fractions over there, and C cannot be 0 because of that fraction right there. All right, so let's divide first numeric fractions, and then we'll look at algebraic ones. So here's a very simple numeric fraction, 1/2 divided by 1/4, and what that means is how many 1/4 are there in 1/2? Well, obviously you know there are 2 1/4 and 1/2. I purposely made it easy. Okay, so if we're going to divide 1/2 divided by 1/4, it means we can take 1/2 and multiply it by the reciprocal of 1/4, which is 4 over 1. And 1/2 times 4 over 1 gives us 4 in the numerator and 2 in the denominator, which then simplifies to 2. Okay, so let's use that same set of steps to divide algebraic fractions. Okay, so we have L over 4 divided by W over 3. So again, we're going to multiply L over 4 by the reciprocal of W over 3, which is 3 over W. And L over 4 times W over 3 gives us 3L in the numerator and 4W in the denominator. Now we want to check that one too. So we're going to take the original equation, okay, and our final equation and set them equal to each other. And then we're going to pick numbers that are easy to work with and put them in both the original equation and the final one and make sure we didn't make a mistake anywhere. So we're going to use 8 and 6 again like we did in the last example. So L over 4 becomes 8 over 4. W over 3 becomes 6 over 3. And 3L over 4W becomes 3 times 8 over 4 times 6. Okay, so 8 over 4 is obviously 2, and 6 over 3 is obviously 2. So our original equation has simplified from this down to 2 divided by 2. And obviously 2 divided by 2 is 1. Our equation as a result of our division, the original one was 3L over 4W, that became 3 times 8 over 4 times 6, which is 24 over 24, which is also 1. So our division of the algebraic fractions was correct. Okay, then the last thing we're going to talk about is how to reduce algebraic fractions. Well, not surprisingly, you reduce algebraic fractions the same way you reduce numeric fractions. Okay, so if you had like 4 over 2, you could divide each of them by 2, and you get 2 over 1. Okay? It's the same thing you're going to do with algebraic fractions. So, the way you do that is using a property called the equal fractions property. That says that if you have real numbers a, b, and k, and b and k are not 0, because they're going to be in our denominators, then this original fraction of a over b is equal to this fraction of ak over bk. Because if it was like we just had 4 over 2 is equal to 2 over 1, right? Because basically what we're doing is we could multiply both the numerator and denominator by 2 and we get the same thing. That's what this guy right here means. You could multiply the numerator and the denominator by the same thing because that means you're multiplying by 1. All right, so let's do it first with numeric fractions and then apply that to algebraic. So here's a very simple one, 42 over 7. Well, I'm sure you already realize that's 6, but the way you were first taught that was to have you realize that 42 is equal to 7 times 6. And then once you broke it out into its factors, you would cancel the two 7s, and you would just have 6 in the numerator, okay, and 1 in the denominator. So 42 over 7 equals 6 over 1. Okay? Let's use that same idea for algebraic fractions. So you can see this is the same numbers in this algebraic fraction. I've just added some variables to it. So 42ab over 7a, and we're going to reduce that. Well, the 42, like we said, is 7 times 6. Now the a and the b is obviously a times b. So if we break it out into all its individual factors, that's the fraction we have, 7 times 6 times a times b over 7 times a. And same as we did with numeric fractions, we're just going to cancel anything that's on the numerator and on the denominator, because those things that are on the numerator and denominator are equivalent to 1. Okay, so in this one here, we can cancel the two 7s because they're equivalent to 1, 7 over 7, and we can cancel the two a's because a over a is equal to 1. And what we're left with after we cancel the two 7s and the two a's is 6b over 1. So 42ab over 7a is equal to 6b over 1, or just 6b. So let's check that. Let's take our original fraction and our reduced fraction and put numbers into a and b and see if both sides are equal to each other. So the numbers we're going to put in are 10 and 5 because they're easy to work with. So if we put in a equals 10 and b equals 5, we get 42 times 10 times 5 over 7 times 10 on the left side. And we get 6 times 5 over 1 on the right side. All right, so 42 times 10 times 5 is 2,100. 7 times 10 is obviously 70, okay? And 2,100 over 70 reduces to 30. On the right-hand side, we had 6 times b over 1 when we were done reducing it down here. And if we put 5 in for b on the right side as well, we get 6 times 5 over 1, which is obviously 30 over 1. So it ends up being, yes, 30 equals 30. And that's how you reduce algebraic fractions.